Hello everyone, my name is WONG and my matrix number is 2929XX. Today we are going to dive into the fascinating world of differential and integral calculus of function of several variables. This topic is a cornerstone of higher mathematics with wide-ranging application in physics, engineering, economics, and more. It allows us to understand and model complex systems that depends on more than one variables. Differential and integral calculus of function of several variables extend the concept of differentiation and integration, which you may already be familiar with from single variable calculus to function of multiple variables. These include concepts like partial derivative, multiple integrals, and vector calculus. In our real life, we always deal with functions that take several inputs and produce an output, allowing us to model more complex situations. Multiple integrals help us to understand the total accumulated effect of a function over region in multiple dimensions. Let's start with the concept of a partial derivative. This is the derivative of a function with respect to one variable, keeping all other variables constant. It is represented by the symbol of this. And for example, if we have a function f of x and y, the partial derivative of f with respect to x is represented as partial derivative f over partial derivative of x. Now, let's talk about Clairaut theorem. A fundamental law in multivariable calculus is that if a function has continuous second-order mixed partial derivative in a region, then the order of differentiation does not matter. In other words, for a function f of x and y, the second-order mixed partial derivatives are equal. For example, fxy is equal to fyx. For example 1, we will find the partial derivative of x and y. First, we will find the partial derivative of x. So, f of x is equal to 5y plus 2xy power of 5. Since y is constant, so we will not differentiate the y. Second, f of y is equal to 5x plus 5x squared y power of 4. Since x is constant, so we will not differentiate x. For example, for example 2, we will find the fxx is equal to 5y plus 2y power of 5. Second, we will find the fyy is equal to 5x plus 20x squared and y cubed. For fxy is equal to 5 plus 10xy power of 4. And for fyx is equal to 5 plus 10xy power of 4. fxy is equal to fyx because of the Clairaut theorem. For example 3, suppose we want to evaluate the double integral of f of x and y is equal to 9x cubed y squared over the region R equal to 1, 3, and 2, 4. So we can write as double integral over region R 9x cubed y squared dA. The lower limit and upper limit is already given, so we can write as lower limit is 1, 3, upper limit, and 2, 4, 9x cubed y squared dy dx. So first, we have to integrate the dy first. So after integrate, we can get 3x 3 y 3. dx, and we can the 4 and 2. After substitution, we can get the answer 16x x cubed dx. After that, we can integrate it and get the answer 42x power of 4 and the upper limit 3 and lower limit 1, which is 42 times 3 power of 4 minus 42 power of 1 power of 4. And the answer is 3360. In conclusion, in this video, we have explored the basics of differential and integral calculus of functions of several variables, including key concepts like partial derivatives and the law of equalities of mixed partial derivatives like Grillo theorem. These tools allow us to model and understand complex multi-variable systems with application in many fields. I encourage you to continue exploring these concepts as they form the basics for many advanced topics in mathematics. Thank you for watching.